Have you ever wished you could boost your memory, sharpen your focus, or even increase your overall intelligence with just a few dedicated exercises? It is an incredibly appealing idea, the promise of a smarter, more agile mind. When it comes to brain training programs, robust evidence for what scientists call for transfer is indeed largely lacking. This means that while you might get better at the specific tasks within the training program itself, those improvements rarely carry over to unrelated cognitive skills or real-world abilities. The primary reason for this absence of for transfer lies in the brain's incredible capacity for what we call domain specificity. Our brains are exceptionally efficient at learning and optimizing for very particular tasks. When you practice a brain game, your brain develops highly specialized neural pathways to excel at that specific game. It is like becoming a master at playing a specific video game. Your skill in that game does not necessarily make you better at playing an entirely different sport or solving complex math problems. Furthermore, many studies demonstrating near transfer, which is improvement on tasks very similar to those trained, often suffer from methodological limitations. These can include small sample sizes, inadequate control groups that do not account for placebo effects or general practice gains, and a tendency for positive results to be published more readily than negative ones, known as publication bias. The concept of general intelligence is a highly complex construct, and current brain training approaches tend to be too narrow and targeted to influence such a broad cognitive capacity in a meaningful way. So, what can you do with this information? When encountering claims about brain training, it is crucial to adopt a critical perspective. Look for studies that rigorously test for transfer, utilizing diverse, entrained tasks and active control groups. Understand that while specific skill training can be beneficial for those particular skills, expecting broad, generalized cognitive improvements from current commercial brain training programs is not supported by the bulk of scientific evidence. Instead, focus on well-established strategies for cognitive health. Consider the active control paradox in research, where studies that include an engaging but irrelevant control task often show no difference compared to the brain training group. This highlights that simply engaging in any novel or stimulating activity can sometimes produce similar improvements to specialized training, underscoring the importance of novelty and engagement rather than the specific training itself. This speaks to the brain's inherent adaptability and its preference for novelty to drive neural plasticity. Ultimately, while the idea of a quick cognitive upgrade is enticing, the current scientific landscape suggests that for profound, widespread cognitive enhancement, focusing on a holistic approach to brain health remains the most effective strategy. Activities such as regular physical exercise, a balanced diet, sufficient sleep, and continuous learning in diverse real-world contexts offer more robust and scientifically supported pathways to maintaining and improving your cognitive function over the long term.